Okay, I'll start. So, good afternoon. My name's Carrigy. I'm a designer and researcher, and I'd like to talk to you today about my experience working in the post-industrial world, working in the world of information technology, and the role of craft and design innovation within this context. So, I originally trained as a textile designer. I graduated from NCID in the late 80s. And my training in NCID was very much as a designer maker. We learned how to print by hand onto fabric, to make all our colour separations by hand, paint up all the repeats by hand. Pretty much everything was done by hand. So when I graduated, there was no work in Ireland, so I went and lived in New York and London, and I worked in the textile design industry, sort of handcrafting design prototypes for industry. Then I returned to Ireland in the mid-90s and kind of struggled away as a designer, mainly exporting. I found mainly exporting to the UK and the US. There still wasn't a huge amount that I could find in Ireland in terms of being a designer maker. The whole manufacturing idea didn't really add up because just the economies of scale, print is about multiples, and there isn't enough people in Ireland to buy those multiples. To export was costly, blah, blah, blah. So anyway, in 2006, I'll get to that in a moment, but basically, in 2006, I won the Adaptive Kraft Award, which was an initiative sponsored by the Crafts Council of Ireland and DCU, and that got me into wearable technology. And that was kind of a sort of a turning point in my design practice, in that I started looking at the possibilities of digital media and how that could be integrated into garments and integrated into craft practice. So up until then, I'd made a graduation from hand painting into actually using a computer and using digital tools, but this integrating actually digital capability into a garment was a whole new way of working. And since then, I've actually ended up working in game design, designing augmented reality games for mobile, which in a sense was kind of layering kind of patterns, visuals, images, sounds over an environment, to create a new experience for the player. So basically, I believe for a number of reasons there's an important role for design and craft skills in the post-industrial world, and opportunities to develop new models of design and craft practice are opening up in the era of information technology, particularly in the space of IT, where it converges with the physical and the real world. And I believe this for a number of reasons. The first reason is that digital capability is being embedded into everyday objects. Therefore, the design of these digital artifacts is as much about material culture as it is about information technology. Secondly, the digital interfaces are becoming more physical, and we've seen this with iPads, iPhones, touch interfaces, also digital games like the Wii, like Connect, where your body is actually used as an interface. So I think that the people who design these need to know about physicality and how people physically interact with the product. And then thirdly, as Malcolm McCullough succinctly puts, the more the interactive technology mediates everyday experience, the more it becomes a matter for design. So as digital capability becomes more universal, functionality will be less of a novelty, and the form and the concept of a digital object will be its unique selling point. So I believe that these 3 points basically represent an opportunity for a craftsperson or designer within this space of convergence between information technology and material objects. So the adaptive craft, sorry, just lost my mouse. Just going back to the Adaptive Kraft Award. As I was saying, that was a bit of a turning point. The award was set up to encourage a dialogue between scientists, in DCU and computer scientists and material chemistry scientists and the Crafts Council of Ireland. And the idea was to use smart textiles for wearable technology applications. So wearable technology kind of has been around since the 80s, and Steve Mann is one of the main proponents, was one of the first proponents of wearable technology. And if you look at this image, you can see how it changed from the early 80s of what he considered to be wearable to something later on in the 1990s where you had some eyeglasses with camera embedded in it. So really, now, Philips and there was various companies that were starting to use different types of textiles, so it wasn't really starting here, but this is kind of the background of wearable technology. Sorry, I keep losing my mouse. So basically, the researchers in the AIC were working with smart textiles that could sense stretch and pressure. And these obviously were kind of more in line with what would be truly wearable. And they were looking for an application for these smart textiles. So in response to that, I came up with two applications. One was smart yoga wear, which was a sensor-enabled mat and garment that provided audio and visual feedback to the wearer's balance and posture. And Jakari Jungle, which was an interactive dance performance that took place in the Kilkenny Arts Festival, where the projected backdrop was controlled by a sensor-enabled armband. Sorry. No, that's better. So basically, the conductive textiles, the way they work are essentially the smart textiles are conductive textiles, and they're made by applying a conductive polymer to the existing textile substrata, and then the sensor readings can be established by passing an electric current through this conductive textiles, and any realignment of fibres caused by applying movement or pressure will cause a variation in the current. So, for example, a conductive lycra is stretched, the fibres in the knitted structure become more closely aligned, making the lycra more conductive. And then briefly, the way it works is the sensor needs to be connected to a mote, and then the mote converts the analog signal of the electronic current. It also has a battery in it. It converts this analog signal into a digital signal, and that's wirelessly transmitted then to the computer. So basically, there were a couple of pros and cons to how the system would work. The advantages were that the sensors were made of the textile substrata, so they weren't that invasive, and the device was miniature. But there was a difficulty with making a connection between the soft textiles and then the hard electronic motes. So initially, we looked at trying to just weave the wires into the fibre. That obviously wasn't going to work because you've got stretch and all of that. So working on that, we looked at using clip-ons that would clip onto the textile strata, and then you could solder the wires onto the clip-ons. So here's one of the first prototypes, which looks a bit like Steve Mann kind of idea. And certainly this is where actually the difference between what we would call making and designing, and maybe what a science laboratory would consider to be making and designing. In scientific research, once you've actually proved the point that something works, that's kind of job done. Whereas my job as a craftsperson, as a designer, was to take this a step further, whereby it could actually be a wearable that you could imagine wearing in a context like practicing yoga. So one of the main things was the circuitry, how to make the circuitry flexible. So we experimented with a couple of different methods, maybe trying to use the wires. kind of bending the wire so that when it stretched, that there would still be wire, that the wire wouldn't stop the wearer from kind of bending down. And we tried using different types of conductive ink. That didn't really work because you've got stretch. It pulls the current, it pulls the printed conductive material apart, which breaks the connection. So finally came up with conductive threads in a zigzag stitch that would be flexible, non-invasive, and also washable. So this took, I mean, as a craftsperson, it took a few iterations, a few ways of making before the final solution came. And I think that it's very much, as a designer, you couldn't really say, oh yeah, this will work. It had to be a hands-on process of actually working with the materials to know whether something was going to work or not. So the way the Smart Yoga wear worked was that we selected different sites whereby the sensors would be placed. So this is just looking at knee sensors. And then as the practitioner practiced yoga, they would make different bends and they could get feedback as to how much their body was aligned based on the sensor feedback. So this is the final product, close-up of the final product. The moat had to be detachable, so that was just placed in the part of the body that was least, it was going to cause least amount of problems for the wearer. The moat can be taken off so the garment can be washed. And you can see the circuits there are, they're with the zigzag conductive threads, and they're totally stretchable and totally non-invasive. So they kind of match the inherent qualities of the textile sensors. So the next step was really to translate the data that was collected. So initially, you would get what was related back to the computer was a bar graph. So that really wasn't going to communicate to the wearer, to the practitioner, how their practice was going. And there was a lot of debate as to whether we should make it, very sort of productivity based. You've completed so many bends, you've done so, and I just didn't feel that that was really going to enhance the yoga practitioners, the general practice. So I came up with an idea of using a mandala that would, it was sound and visually based. And I worked with a programmer, Nikki Ward, that we were talking about earlier. And Nikki helped me develop this idea whereby the mandala would change according to how balanced the wearer was. So it just gave a nice kind of external feedback without saying, you're not doing this correctly. The wearer the practitioner could tune into the sound and look at the subtle variations in the mandala and get feedback as to how their practice was working. So then the next application was a little bit more sort of crafts-based in terms of materials-based and reflecting back to my own practice of printed textiles. It was the Jakari Jungle. It was a performance, an interactive performance for children in the Kilkenny Arts Festival. And simply it used an armband, a very simple armband with one sensor embedded into it. And as the Capoeira dancers moved, they changed the backdrop, and the projected backdrop. So this kind of enabled me to explore something that I was also interested in was, where does handcrafted printed textiles begin and where does the process of augmenting a textile with pattern, where does that begin and end? So part of the fabrics were hand printed, other parts were digitally printed, and then you had the virtual print that then augmented the printed surface in random ways while the dancers moved. So just some images of the performance. And then the storytelling, physical theatre and visual representation were employed to create a narrative based upon a children's fable in which the animals change their appearance and undergo a series of transformations. So I felt that this would kind of vaguely communicate to the children without instructing them that sensors they're about sensing transformation, and they're about maybe taking that data and giving some feedback back to you that isn't a bar graph. So this is just the armband. It had to combine sort of tension and flexibility. It needed to be rigid enough to support the stretch sensor, but at the same time be flexible enough to allow the sensor to move freely. The mote was kind of embedded into the armband, and it had to be detachable as well, so that the armband could be washed. And it needed to be robust and strong, so the wearable could survive strong enough the physical activity. Also developed a sensing glove in which there was a narrator who narrated a story, and as she moved, she also was able to trigger the slides. So the mote is then also detachable here. So I suppose while I was working on this project, I was constantly asking myself, what is my place as a craftsperson and a designer in the context of scientific research? And I suppose some of the things I came up with were that skillful making in this interdisciplinary research context, was of great value in terms of producing quality prototypes that could simultaneously test a number of ideas and lend themselves to a more open-ended evaluation, therefore extending the limited parameters of laboratory testing. And I kind of really realised that the importance of real-life testing as opposed to lab testing couldn't be overemphasised. And that's something that I've really taken through into other projects, because a computer programmer may feel that the work is done once the program actually delivers in the lab, but it's not until the users actually start to use the object that you really can test the parameters of the product. I also feel that the value of craft in this context relates not only to the skillful making that is required to physically integrate the digital process into material objects, but that the dialogical nature of craft, the craft process of thinking and making, enables the giving of form to concepts that have been conditioned and formed by the making process. So it's not really, it's not just about being a technician, it's about creating through the process of making, through thinking, through actually working with the materials. And I also felt that the simultaneous relationship with the material, the process and the end user was a kind of unique value of craft in this context. So in conclusion, I felt that craft practice, with its rich tradition of applying tacit knowledge to material and technology of everyday use, is well placed to offer informed perspectives and methods of integrating emerging technologies into the material world. An intelligent and adaptive object can respond to the user and will extend the possibility of personal and individual interpretation, and therefore the maker will be required to focus more attention on the relationship between the user and the object. Craft in this context can offer more than skillful making or an aesthetic packaging for digital technology. It's a holistic process which can serve the user by enhancing the experiential qualities of the application. The dialogical and open-ended inquiry that characterises craft practice becomes embedded in the object, both in its form and in the thinking embodied by that form. Craft practice is a holistic approach that utilises technology not as an end in itself, but in relation to how it can benefit and enhance the end user. And then also, just as an extension of that, I'd just like to look at some of the other work that I've been doing since then. One of the kind of frustrations I had when I was working with the sensor technology was that it was very much So part of the frustration working with the textile sensors were that they became basically an on-off switch. And I felt that it was hard for the viewer when they're watching the Jakari Jungle performance to really see, when the change was happening, when the actual the projections were being changed as a result of the sensors. And I felt that I really wanted the users to be able to experience what it was like to manipulate patterns and colour and texture. So this is a project I worked on with a group of students at Trinity College. I went back to do a master's. I felt, working with adaptive craft, I felt, yeah, I can get this sensor data, but what am I actually going to do with the data? And I felt that I didn't really know enough about digital technology to be able to express myself through it. So we worked on this project and we coded all of these patterns through basically ones and zeros. They're all codes. None of the images they're all created by the computer. So you're actually getting right inside the craft of the code and making the images. So it's quite a different experience from working with, say, Photoshop or a program whereby you've got a set way of working, whereby you can apply a filter that Adobe have given to you as a package. We were able to actually create everything from scratch, including the touch screens. We used PVC and we back projected onto the environment, and we used a camera which picked up UV light to track these brushes. And inside the sort of Japanese brush, there's a little UV light, and that's been picked up by the camera. So everywhere that's a point that the computer then applies the code of the pattern onto that point. So I don't know if that explains it well, but I felt that it just really gave people direct access to manipulating the patterns. And this was like a huge jump from where I'd been with the adaptive craft, where I felt quite limited. And it was really nice that basically all ages were able to use this technology. There was no explanation. You could just jump straight in, young people, old people, everyone just got it. So that was a really nice experience. And then from there, I started working in Haunted Planet Studios, which is actually we don't. Let's not have Mads. Sorry, Mads. Just. Mads is the principal investigator there. Basically, I came in as a designer. As a game designer, also an interface designer and experience designer for a game that is a ghost story whereby the gamers move around the city hunting for ghosts, and they track down the ghosts using this radar. And then they can photograph the ghosts, and they get to hear pieces of narrative about the ghosts, and they build up an idea of a picture, a narrative story about the environment, about the history of the area, and as they progress through the game. So I suppose it is a bit of a jump away from textiles, but I did feel that a lot of my initial experiences as a designer maker in printed textiles, those skills still held fast. That basically, with printed textiles, the first thing you do is identify the fabric. What is the fabric? What are its limitations? what can I apply to this fabric, and how can I communicate that to the user? And I think the same thing with GPS technology, with touch, with vibration feedback, with audio. It was about defining what the limitations of the technology were. And the same actually with the responsive environment. I felt that once you could define the technology, once you had the tacit knowledge of the technology, in the same way as you would have the tacit knowledge of material in more traditional craft processes, once you've got that, then you can be fluid in your use of the technology, and essentially you're crafting, you're designing and crafting in the same way as you might a very traditional material. You're just using a different material, a different process. So yeah, that's really the end of that. So thank you very much.